Well, hi, geometry. Welcome to... I can write two column proofs. That's interesting, 0. And I can name proofs and properties. So here we go. This is our proof intro. We will be doing a lot of these throughout the year, but they don't have to be as scary. So trust me that in the beginning, it'll be a little rough, but the more you practice, the better. And the reason why these notes are already written out is because I messed up the first video. So here we go. Let's try it. Covering the answers up. Hopefully you didn't see them. If measure, we need to, it says solve the following, but we're just going to solve it and list what the statement is. I probably should change that, but here we go. Measure of angle 1 equals the measure of angle 3. Then the measure of angle 3 equals the measure of angle 1. And that is symmetric property. Symmetry. Okay, so how about this one? If AB equals CD and CD equals TU, then AB equals TU. That is transitive. I like to say we cut out the middleman there. We get rid of those two insides. Next one. If RS equals WX, then RS plus AB equals WX plus AB. Basically adding AB to each side. That's your addition property of equality. We're going to be using these properties today with the proofs, so that's why I have them in the warm-up. And the next one, if the measure of angle EFG equals 28 and the measure of angle GFH equals 62, well, I'm adding those two angles together, so that means I'm going to add the measures together, 28 plus 62. So that would be a substitution, just substituting and plugging in. All right, so here we go. A proof is a logical argument that shows a statement is true. There are several formulas for proofs. A two-column proof has numbered statements and corresponding reasons to show an argument in logical order. There's always been the kind of debate on whether or not we should do a column proof, not a column proof, a paragraph proof, but the two-column proof is still stuck. It's still there. And I know a lot of your parents will say that you've never used this before, but whenever you're using any type of logical reasoning, you're using this. All right, so this is the anatomy of a two-column proof. You're always going to be given a given portion. You'll be given a proof, and sometimes a diagram, sometimes not. You might have to provide your own diagram. And then you'll have to make your own two-column proof. One column will have the statements, one column will have the reasons. Now, in the beginning, I will be giving you statements, and we will have to fill in the reasons. Okay? So here we go. 9 times out of 10, there's some occasions where you won't put it first, but take your given statement, AB plus AB equals AC. So we're saying 2 of these equals the whole length. You write given. You'll always get a point for that, so don't skip this step. Now, I know that AB plus BC equals AC. That's our segment addition postulate. So we learned that in the past. Well, look at this. AC is equal to this, and AC equals to that. Well, can't we set them equal to each other? But AB plus AB equals AB plus BC. So that'd be transitive. It's kind of like your middleman. We eliminated the AC part. Well, now, to get this statement, I'm going to subtract AB on both sides. Subtraction property, I now get what's left over, AB equals BC, and that's what we're trying to prove. So usually your given statements in the beginning, the statement you're trying to prove is going to be in the end. All right? That shouldn't be too bad. Of course, that one was a little bit on the easier side. Okay. Example 2. Once again, you're going to be given a given portion, a proved portion, sometimes a diagram, and you will have to fill out two-column proof. Okay, so what I'm going to do is draw a line right here, so I now have 2 columns. All right, so I ask you to fill this one out. I told you it was given, so take the information from the given and write it in. Measure of angle 1 equals the measure of angle 3. I also made this arc to show that those are the same. Now, using angle addition postulate, I know that measure of BED is equal to measure of angle 2 and the measure of angle 3. Okay? And I know that, look at this, this is the same, this is the same, but I switched these two. Why? Because that's a given statement. Angle 1 and angle 3 are the same, so you can substitute that in. Alright, now I know measure of angle BED equals this. Measure of angle BED equals this. So now you can set those technically equal to each other. Oh, actually, I'm going to... Well, we skipped that, didn't we? Just hold on. I did it in this one. Measure of angle 1... measure of angle 2 plus 1 is measure of angle BD. Sorry. Okay, measure of angle 1 plus the measure of angle 2 is equal to CEA. That's angle addition postulate. Now I'm using these two as my transitive. Measure of angle 1 angle 2 equals this. Measure of angle 1 angle 2 equals this. You can set those equal to each other. There's your transitive. Sorry, I was getting ahead of myself, and I really don't want to do a third video. It's late. Okay, theorems. Now, these may look familiar. We've seen them with the measures of segments, but now also works for congruence of segments. And I know a lot of you get these confused, but here these are saying the segments are congruent. And we know from congruent segments, the measure of the segments are the same. So it's two different things. Also, we have congruent angles, and we know the measures of the angles are the same. So let's move that on and do example 3. Okay, so name the property illustrated for the statement. It's probably directions I should have for my warm-up, huh? Angle A is congruent to angle A. That's reflexive. So whenever you see the same thing, think of the mirror. It's the reflexive property of angle congruence, or you can say congruent angles. You'll see a lot of abbreviations here. Segment PQ is congruent to segment JG, and JG is congruent to segment XY. Then segment PQ is congruent to segment XY. Again, our middleman was JG. It's your transitive property of congruent segments. If angle A is congruent to angle T, and angle T is congruent to angle A, we just swap them, switch them around. That's your symmetry property of congruent angles. All right, example 4. Here we go. So again, you're given, your prove, and I think I had to draw that in for you. I'm not sure. Take a look. Okay, so I know this seems ridiculous. We want segment LM, we're given segment LM is congruent to segment NP. What we want is segment NP is congruent to LM. So we are proving your symmetry property. Okay, so I know it seems redundant. I have to admit, I was never a fan of this proof. Let's make our two columns, and here we go. So right away it's given. Well, I know if my segments are congruent, their measures are the same. Notice I don't have a line above him, and the congruent symbol is now equal. So that's your definition of congruent segments. We do know that symmetry property of segments does hold true. So we're not using the congruence because we're proving it. So we already do know that I can switch those around because that is symmetry property. Okay? And if the measures are the same, then the segments are congruent. And that's their definition of congruent segments. So this is your simple proof to prove symmetry property. Symmetry property of congruent segments. This one's for angles. Alright, here you go. Here's the one I messed up. If you'll notice, there's like some post-it notes over it, so I'm just going to have to write over this one and deal with it. Here we go. So the distance from a park to a pool, so that's from here, I'm going to mark it, is the same as the distance from your house to school. The school is between the pool and the house. Let's see here. Prove that the distance from the park to the school, so you want to prove that this distance is the same as the distance from your pool to your house. Alright, so here we go. Let's hope I don't mess this up again. Okay, we are given that AB is equal to CD. Okay, they tell us that. We want to prove that AC is equal to BD. This is kind of like going backwards from that problem we did prior. So here we go. number 1. I'm going to write down AB is equal to CD. Well, that's given. If you never know where to start, at least do that. Okay? Gets you somewhere. Then we also know that BC is equal to BC. Well, if a segment is equal to itself, the measures, that's reflexive. Alright, so I'm going to take the AB and CD and add BC to both of them. So number 3, we're going to take the AB and add the BC. We're going to take the CD and add BC. That's just addition property of equality. Alright, now also I'm gonna put in here for segment 4, segment addition postulate. So here we go. So AB plus BC equals AC. So AB plus BC equals AC. Plus BC equals AC. And we're going to put 2 in here, so we can do that. We also know that BC plus CD equals BD. And for both of those, that was segment addition postulate. Okay, so what I do know is, let's see here, AB plus BC, it's right here, and BC plus CD is right there. So that means I know that AC equals BD. Check to make sure that's what you're looking for. So by using the segment addition postulate, if I kind of replace these two with that, we get AC equals AB. And that's substitution. I'm basically substituting, replacing. What do you think? Okay. Nice response. All right. This last one, hopefully we can not make this video too long. Okay. MP bisects angle LMN. Okay, we know that it's going to cut it in half. So that means 2 of the LMPs will equal LMN. We know that. All right, here we go. Number 1. Let's draw our column. Write down your given statement. MP, ray MP, bisects angle LMN. That means it's going to cut these 2 in half. Okay? Okay, now, I just marked these, but why did I mark them? Because I know what an angle bisector does. An angle bisector is going to cut that whole thing in half, so I'm going to write that down. The angle LMP, that's the top one, is congruent to the angle NMP, that's the bottom one. Why? Because this was a bisector, and what does bisectors do? It makes those 2 congruent. So that would be definition of angle bisector. Okay, now number 3, LMP plus NMP is equal to the whole thing. That's your angle addition postulate. Oh, look, I wrote angle twice there. So this plus this is equal to the whole thing. So far, so good? Well, watch this. I know that these 2 are congruent. So I'm going to replace this with that. So angle LMP, and I'm going to substitute this in for NMP. So that's going to equal angle LMN. So I just substitute it in. And look at this, I've got two of those. The angles, we have two of them, the measure of LMP is equal to the measure of angle LMN. I just simplified. Now, I know you're disliking the detail that they expect with geometry, but bear with it. It does become a little easier in the long run. You'll notice that this assignment has been split into 2 different days. There's a reason. Take care.